In this video, I'll show some of the new and updated things in RayTK version 0.33, which is now available for download. It's going to be more of a quick overview rather than a full walkthrough, so I'll cover these features in more detail in later videos. One of the most visible areas that's changed is the palette. In previous versions, operators were organized into a relatively small number of categories, like filters and fields. Starting in version 0.33, there's an alternative mode that groups operators into smaller, more descriptive categories. The goal is to hopefully make things a bit more discoverable. Some categories, like camera, are the same as what you may be familiar with already, but other things like the color field are new. So the color field category holds all the different types of operators that generate color-based fields. Then we've got combiners, different helpers for controlling parameters and so on, conversions between different coordinate spaces and types of values, ways to modify field values, and so on. If you prefer to see the old categories, you can use this toggle at the bottom here, which will go back to the old filter and field categories that you may be used to from previous versions. Another thing that you may notice as you scroll through is that some operators will have a marker next to them indicating that they are new or updated. So these indicate changes in the most recent version of the toolkit that you're looking at. So in this version, there were a couple of new light operators, various updates to other lights, and so on. So those will be indicated here in the palette. And that will be updated with each release of the toolkit, so you'll get a chance to see what is new in each version. Now we'll get into some of the new operators. First up is moduloLine. moduloLine is similar to modulo 1D, where we define an axis and we repeat space in slices along that axis. But instead of using just either the X or Y or Z axis like modulo 1D does, with moduloLine you can define two different points in space, and it will generate a line between those and slice space between those 2 points. So you can move those points around, and you can control how many repetitions there are within that range. And I'll be adding more features to this in upcoming releases. Next is instanceField. instanceField is instancing, but for fields. So it's similar to the existing instance operator, which works with SDFs, which repeats copies of it and then combines them in different ways. So for instanceField, we're combining field values instead of SDFs. So we have a few different modes for how to combine them, like adding, subtracting, multiplying, and so on. And similar to with the instance operator, this provides some variables that you can access which instance of the field is currently being calculated. So one use for that is layering multiple versions of a sine wave with different periods and amplitudes together. So here we've got a single sine wave, and then we're duplicating 3 different copies of it with progressively smaller periods and smaller amplitudes, and then adding up all the results to create this final wave. Another use case for this is with spatially defined fields. So if we have something like a point distance field that is connected to a step field, that gives you a field that is, has one value inside a particular range of a given point, and then other value outside, and then a variable amount of transition between those two. Now with instanceField, we can then combine multiple of those and use the variables to define different positions and different ranges for the steps on each one of them. So that gives you one combined field that's based off of, in this case, 4 different points with different settings for each. Next up is the ambientLight operator. It's pretty simple. One thing to note about it is that for diffuse shading, it basically does nothing because it applies the same amount of light everywhere. But for specular shading, you can get some interesting effects where the light kind of comes from all directions. So depending on the settings in your material, so if you have like a higher roughness, if you have the roughness go all the way up, things get kind of more even across space. And then depending on where your camera is, it will provide specular highlights that are kind of always facing the camera, coming from pretty much every direction in space. Next up is ringLight. So ringLight is similar to the axis light, which is coming from like a single infinitely long tube along one of the axes, but instead of a tube, it's a torus or a ring. So it gives you a position so you can kind of move that ring around. Here we're using distance attenuation, so you can kind of control like how much the light tapers off as it gets further away from that ring. And then you can use it along with shadows, and it will create some interesting effects where it the shadows are kind of coming from different directions depending on where it is in the scene. Next is the limitArea operator. So this is both a way to kind of shape field values as well as a way to optimize scenes. So let's take, for example, a scene where we've got some lighting and we've got shading on that material with both a diffuse and a specular element to it. So the diffuse is kind of the purple part and the specular is these green highlights. So if you wanted to only have the specular apply within a certain area, you can use the limitArea operator to define an SDF that gives you bounds for an area where that operator applies. So in this case, we're using a sphere and saying only use the specular shading within the bounds of that sphere, and then the sphere is moving around. And it gives you some additional settings like blending, so you can kind of smooth the transition between the area where it's being used and the area where it's not. And you can use offset to kind of grow or shrink that area. Now, one benefit to this over doing something like multiplying by another field that defines the areas to kind of zero out the outside areas is that outside the bounds of that area, it doesn't do any of the calculations for that operator. So you're saving a bunch of resources. If you only need specular highlights within a certain area of your scene, you don't have to have all the calculations for them existing all the way outside of that area, even if they're not being used. Next up is the nearestRingPointField. So this is a field that defines a ring of positions in space. So a variable number of them, so you can say, 8 or 6 or whatever. You can move it around and define a radius for the ring. And it produces different kinds of information about those points. So here we're looking at the raw distance. So it's 0 at one of those points, and then it gets larger as it goes away from there. We can combine that with a step field to create an area that's only around the points, and so you can have like a value of 1 near the points and a value of 0 outside of that, or blend however you want. It also can provide the absolute position of the nearest point or the vector from wherever it's being asked about to the closest point. So one use case for this is to apply rotation and have the rotation pivot around different points in space and apply a different amount of rotation within a certain range of each of the points. So if we turn off our blending, a little bit easier to see there. So we're only applying rotation within a certain range of each one of those points. And we're then using the position of that point to provide the pivot around which we're rotating. So as it rotates anywhere within, one of these zones, it's going to be always rotating around the center point that it's closest to. Next up is the radialSlice operator. This is similar to the existing slice operator, which takes a segment of an SDF along a particular axis, but instead of doing it, along an axis, it does it radially around one axis. So we've got a torus here, and then we're basically taking a slice of it by defining a range of angles. And you can control, the width of that slice. You can also give it a start angle and an end angle if you want. You can have it invert, so it gives you the area outside of that slice. And it also, like the slice operator, gives you an option to smooth out the area where it's applying the cut. So here we've got a box frame, and we're taking a slice around the z-axis, and we're then blending out that transition between the area that's kept and the area that's cut off. And that's only a selection of the new operators and features in 0.33. Check out the release notes on the download page, linked in the video description for a full list. I'll be making tutorials that cover these features in more detail soon. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.